Hi everyone, in this lesson you're going to learn how to solve log equations. The steps are, first one is you got to condense to a single log. Then the second step is you convert to an exponential equation, and then the third step is you solve. But before I go over the examples, let me just remind you, based on when we graphed log functions, we can't take the log of a negative number nor zero because they're not in the domain of logs. Okay, and if you don't remember this, you have the notes that were provided to you in class. So let's start with example number 1. So we look at step 1, condensed to a single log. This is already a single log, so that means we're done with step 1. Step 2, you convert to exponential. So then I'm going to take the base of the log, I'm going to raise it to this power and set it equal to 3x. So then 7 to the negative first power equals 3x. Then based on the properties of exponents, I'm going to rewrite this so that the power is positive. So this is the same as 1 over 7, and that is equal to 3x. Then I'm going to write a 1 under that 3x and then cross multiply. Okay, so then 7 times 3x is 21x, and 1 times 1 is 1. So then since I'm solving for x, what I'm going to do next is I'm going to divide by 21. So then the value of x is 1 over 21. And that's all for the first example. On the second example, again, condensed to a single log. This is already a single log. So then we go to step 2, which means we're going to take the inverse of the log, which is the exponential. So this is the base of the log, raise it to this power, and set it equal to what's the binomial, which is the two-term side of the parentheses. So then 3 to the 0 power is equal to 4 minus x. But then the lesson that I covered in class about any value, any number or variable to 0 power is 1, I'm going to use that property here because 3 to 0 power is 1, and that is equal to 4 minus x. Then I'm going to subtract the 4 from both sides of the equation. So then this becomes negative 3, and that equals negative x. Then I don't want negative x, I want positive x. So I'm going to divide by negative 1. So then solution is x equals positive 3. And that is the solution for this equation. Okay, example number 3. For example number 3, again, this is a single log, so I don't have to do step 1. So step 2, take the inverse of the log, which is the exponential. So take the base of this log, which is 2, raise it to the power of 3, and set it equal to x over 2. So 2 to the third power is equal to x over 2. Now 2 to the third is the same as 2 times 2 times 2, which is equal to 8. So 8 equals x over 2. Then again, I'm going to write a 1 on this 8 so I can cross multiply. So then 1 times x is x, and 8 times 2 is 16. So the solution to this equation is 16. Okay, now I'm sorry you couldn't see that. So if you need to pause the video and then copy whatever you need to copy. Okay, but let's move on to example number 4. So for this one here, if you do not see a parenthesis, okay, like this one here, there's a parenthesis. So this belongs to one log. In this case, that 6 is not inside of a parenthesis, so that means we don't have to follow what we did with number 2. Instead, let's get the log by itself. Let's isolate it. So subtract 6 on both sides of the equation. So then this is now log base 3 of 2x equals 4 minus 6 is negative 2. The log is isolated and is condensed to a single log, so we don't have to do step 1. So then raise the base of the log to this power and set it equal to 2x. So then 3 to the negative second power equals 2x. Then again, based on the properties of exponents, I'm going to write this 3 to the negative 2 power or second power as 1 over 3 squared, which is 9, right? So let me just take this to the side in case you don't remember. This is the same as 3 to the second power, which is equal to 1 over 9. So that's how I got this, okay? So then this equals 2 to the x. Again, I'm going to write a 1 under 2x and then cross multiply. So then this gives me 18x, and then 1 times 1 is 1, so then divide by 18. So then we find that x is equal to 1/18 or 1 over 18. And that's a solution to this equation. Example number 5. Notice again, this is inside of a parenthesis, so that means this belongs to the log. So it's not like example number 4, but this log has a 3 in front of it. We need to isolate the log. So I'm going to divide by 3 so I can get the log by itself. So then I have log base 4 of x minus 2 is equal to 1. Okay. From here, I'm going to take the inverse of the log. So this is 4 to the first power is equal to x minus 2. So 4 to the first equals x minus 2. Well, 4 to the first is the same as 4. So then I'm just going to add the 2 to both sides of the equation. And 4 plus 2 is 6, which means x equals 6 or 6 equals x means the same thing. Last example. For this one, there's a plus 8, so I'm going to subtract that 8 from this side and also from the 14. So then we have 3 times the common log of x minus 25 is equal to 14 minus 8 is 6. But then we have a 3 in front of the log, so let's divide by that 3. So then this gives you the log by itself. So this is the common log of x minus 25 is equal to 2. Okay. Then I take the inverse of the log. The base of this log is implied to be 10 because it's a common log. So 10 to the second power equals x minus 25. So 10 squared equals x minus 25. 10 squared is the same as 100. So 100 is equal to x minus 25. Then all we have to do is add the 25. So we can find the value of x. So then the solution to this equation is x equals 100 plus 25, which is 125. And that's all for this video. I'll see you in class. Bye-bye.